be talking to us on refining technology, and he holds a degree in chemical engineering from Politecnico di Milano and an executive MBA diploma from IKOI Business School, having worked for 15 years in oil and gas processing industry and is involved in complex projects worldwide, extensive experience as resident manager and commercial manager in US, China and Australia. Our speaker, Mr. Enrico Cappellini from IKOI S.p.A, joined this company as commercial director 5 years ago and is now active in promotion of innovative technology for precious metal industry worldwide. Ladies and gentlemen, he will speak to us on the recent advances in vacuum distillation technology. Let's give a resounding round of applause for one of our earliest birds in the hall this afternoon, who's been patiently waiting for his turn. Let's hear it for Mr. Enrico Cappellini.
Thank you. Thank you for the very nice introduction. And thanks to all of you to be here. It's a good opportunity for me and it's a pleasure to be here. As per introduction, I will speak today about the evolution of what we call the ALS, the acidless technology, and generally speaking, the evolution of the vacuum distillation technology applied to the precious metal industry. The ALS, for the ones that are not familiar with the technology, it's a pre-refining process. It's a process based on vacuum distillation that is capable to separate mainly silver and volatile components from gold alloys, which would be doré bars coming from mines or any type of feedstock. It is a pre-refining process that can be used before the traditional process of aqua regia or electrolysis. The principle of the process, and generally speaking, the principle of vacuum distillation is to process the metal in a metal form in a vacuum chamber in a way in which we reach under vacuum a high temperature and we start the evaporation of selected components. So some part of the metal will evaporate during this process and they will be condensed in metal form in a condenser that is on top of the crucible. So the process, as you may understand, it's a process that does not involve any chemical and does not produce any byproduct. This is the reason why the process is called acidless process. The basic principle, the physical principle of the vacuum distillation is based on the concept of vacuum pressure. Each metal within an alloy has a different vapor pressure. We can say that has a different capability to evaporate depending on the condition. And using this principle in which different metal evaporates at different condition, we can separate and selectively evaporate only the metal that we want to separate. Specifically, this is done in our industry mainly for silver and some other components like lead or zinc that can be impurities in our alloys. Without going into the formulas that are in the presentation, this slide is just to explain something that is a concept of, again, the metal distillation. Metal distillation is an excellent process, but it's not a process that can separate any kind of metal. There are some metals that can be evaporated, can be distilled, and some other that will not be distilled. This is the principle that we use to separate silver and gold. And the principle is that the vapor pressure has to be quite different between the metal that we want to evaporate. There should be some, we call it distance in terms of curves, in order to be selective in the evaporation. The other formula, which I'm not going into details, but it's important to understand as a principle, is that the vacuum distillation and the ALS process is a very fast process. We can arrive to separate up to 500 grams per minute of silver during the process, which means that in 1 hour, we can actually achieve a separation of 30 kilos of silver in an alloy. It's based on this, it's one of the fastest refining process in the industry. There is no comparison with the aqua regia process or with even the Miller process or the electrolysis process. And one of the most important characteristics of the ALS and the vacuum distillation is that there are no chemicals, there are no byproducts, so it's by definition a very green and sustainable process. It's a process in which we take only the material that we need to process inside our machine and we obtain two metals at the end. From this point, we can move forward with the final refining. And this is one of the reasons why this technology is becoming more and more common in many, many refineries, especially the big refineries in which the environmental issues are very important and foremost in any kind of consideration. This is basically, very quickly, what is the vacuum distillation technology so far and what is the ALS technology so far. Going forward, the technology evolved over the years, and today we are presenting for the first time some application of the same technology to different kind of feedstock. And in particular, specifically in this conference, we are presenting the technology that is applied to jewelry industry and carat gold. Mostly, the ALS and vacuum distillation technology has been used to process feedstock that are coming from mines, worldwide with high silver content, but the capability of the process is very, very powerful also for the carat gold and the secondary gold alloys. And for this reason, one of the things that we introduce, and it is presented for the first time, is a machine that is based on the vacuum principle technology, but is a lot smaller in terms of batch size and a lot simpler in terms of operating and maintenance. It's a 1 kilo machine, which has all the main feature of the other machines that we already produce, which go up to 200 kilos. And it's a benchtop machine that can be used by any jewelry maker or jewelry refiner that wants to process the scrap of his own production. So to give you an example, a jewelry maker that is casting his jewelry and has the what is called the casting tree as a scrap, can process this material inside this machine very easily, very quickly, in order to improve the process of refining of his own material, getting the material back into the cycle and produce other jewelry products. To give you a bit of an overview, this machine is designed to be very simple, very compact. It's a benchtop machine. It's about 100 millimeters wide and 600 millimeters tall, so it's very, very compact in terms of process. And it's a machine that will deliver and can deliver a lot of benefit for the refiners that are redoing the work with jewelry scrap with 18 carats or 14 carats. First of all, this can lower the operating cost of these activities of refining the scrap. And it's also quite simple. It doesn't need specialized technology or specialized technician to run it. It doesn't need a chemical background or information about and knowledge about chemistry to run. And it's quite simple to operate almost by anybody. So it's really a machine that by design has been thought to be operated by any small operation that can benefit from it. To give you an idea about the possible benefit of introducing this kind of technology into the refining of carat gold, on the screen you see two different processes. Details will be available. I don't expect anybody to read the process, but it's basically a comparison of a classical aqua regia process applied to a jewelry alloy and the possibility to introduce the ALS into this process. And the advantages are multiple, starting from fast recovery and going into the possibility to eradicate most of the effluent and the byproducts that we produce using the aqua regia. This will lead to a better recovery of the gold that is contained in the alloy. And to summarize, the capability that we have with this machine and the benefit that we can give using this technology, generally speaking, and this machine specifically for the jewelry industry, is to have a lower inventory as gold, because in this way the gold is available a lot faster, to have a very low operating expenses, low or negligible gold loss during the process, because the gold will not go into any byproduct or any effluent, to have less cost also to recover the silver from the alloy, and a better metal control. This is a machine that works very, very efficiently on the batch. Everything that is processed within the machine stays in the machine. It doesn't go outside as a fume or as a liquid, and it's very easy to recollect all the metal that is processed within the machine. And it's also a very easy and friendly type of machine that can be operated without a huge knowledge in terms of processing and a new knowledge in terms of chemistry. So we think that this would be the first and the best place to introduce this machine, which is an evolution of the technology that we already apply to many other refineries. And this conference was actually probably the best place in our mind to present this for the first time, and to give some information, preliminary information about it, and to provide obviously information also in our stand for anybody who is interested in this kind of machine, and generally speaking also in this kind of technology. This is my quick and brief presentation, but if you have questions or if you want to know more, I'm here for the next minutes.
Hello, good afternoon.
Good afternoon.
You said there are little losses. What is the quantum of losses in this refining process?
Yeah.
You said there are very less silver loss, very gold, little.
Yeah.
So what are the losses as compared to aquarija process?
Look, we have experience on the metal losses of this process. They are in the order of 0.001% of the metal that is put as a feedstock. This is an empirical measurement, but it comes also quite easily to understanding the process. The process is inside a vacuum-sealed chamber, and everything happened inside with no fumes and no liquid going outside of the chamber. So once the process is finished and the chamber is clean, all the metal is recovered.
If there's an alloy which contains more of silver and less of gold,
Yeah.
What will be the purity of silver and gold which is recovered by this process?
It depends on the feedstock that we put in. The purity of silver is usually up to 98, 99%, depending on how you run the process. The purity of gold, it depends on the other base element that you have in your alloy. I'll give you a simple example. It is quite easy to separate silver from a karat gold alloy, but it will not be possible to separate copper from the gold. So you will have in your separation silver that is almost pure, but copper that will remain with the gold.
You acidless refining basically are trying to avoid acids. It's
Yes.
a clean operation, there's no acids required.
Yeah, there
But
is
since
no.
the purity achieved is less than marketable purity, which we say anything less than 9950 cannot be sold in a market. You have to take it to 9950 and above purity. For that, you again require a process which involves acid.
That is correct. Let me try to explain what is the reason and the meaning of this kind of process. When you have an alloy with a silver content that is, let's say, 15% or more, you cannot go straight to aquarija, or you cannot go straight with one pass of aquarija and recover all of your gold. There are some tricks to improve this percentage, but basically speaking, from the chemical point of view, the aquarija will create silver chlorides that will stop the proceeding. In order to avoid that, there is a chemical process that is called a nitric acid dissolution or acid parting, which is very intensive. The acidless separation is an alternative to this process. So in this sense, you reduce significantly the use of acids, but it's not a full refining methodology. So you will need a second step refining, whether it's aquarija or electrolysis. It depends on the operation of the single refiners. So in this sense, we call it acidless because it's a pre-refining step that doesn't need any acid or any chemicals.
So what happens to PGM?
To PGM, they will stay with the gold. PGM will stay with the gold, so they will follow the gold refining route. They will go through either the aquarija in this case, or they will precipitate as a anodic sludge in case of electrolysis.
And how does it compare with the aquarija process by cost-wise?
The cost, you ask?
Yeah.
It depends. It really depends on the feedstock. I think that probably we can discuss a specific case on a separate basis.
Well, as Mr. Cappellini said, you're most welcome to also meet up with him outside, offline. And please, I'm sure he'd be happy to answer all your questions. Any others? All right. With this, as we conclude this masterclass with Mr. Cappellini, thank you so much, sir. I invite you to kindly take your seat for a while. Please be in the hall with us till the end of this session. Let's give him a round of applause, everyone.